Over the last few videos, we talked about the ISO systems, quality frameworks, and why certification matters. But today, I want to talk about something many factories eventually discover the hard way. Because even after passing audits, documenting procedures, and becoming ISO certified, many organizations still struggle with customer complaints, scrap, rework, unstable production, missed deliveries, and constant firefighting. And that creates a very uncomfortable question. If the system is certified, why are the problems still happening? Welcome back to Engineering Explained Simply. If you're interested in quality engineering, manufacturing systems, process improvement, and real-world operational thinking explained simply, you are in the right place. And in today's video, we are going to talk about why process capability, especially Cp and Cpk, often reveal problems that audits and certification alone cannot. Because the answer often comes down to one thing: process capability. Now, here is an important thing to understand. This video is not against ISO certification. ISO creates structure, it creates discipline, it creates accountability, and those things absolutely matter. But there is a dangerous misunderstanding in manufacturing. Many companies confuse compliance with capability, and they are not the same thing. A process can be documented, approved, audited, and fully compliant, while still producing inconsistent result every single day. And that inconsistency quietly destroys profitability, delivery performance, customer trust, team morale, and confidence inside organization itself. Because eventually, people stop trusting the process, and when that happens, everything becomes reactive. Imagine this scenario. A customer reports intermittent assembly failures. Production says the dimension passed inspection. Quality says the paperwork is complete. Engineering says the design hasn't changed at all. So everyone starts blaming operators, materials, suppliers, handling, or even the customer. Weeks pass by, meetings happens, corrective actions are opened, but the real issue was never truly understood. Eventually, someone studies the process capability properly, and they discover the process was drifting dangerously close to the specification limit during the long production runs. The parts were technically passing inspection, but the process itself was unstable. And that is where the Cp and Cpk becomes incredibly important, because Cp and Cpk are not just quality metrics, they are signals telling us whether a process is truly predictable or simply surviving inspection. Now, let's simplify this without turning it into a statistics lecture. Imagine your customer says, this dimension must stay between 9.90 and 10.10 millimeters. That range is your specification limit. Now imagine your process produces measurement all over that range. Some parts are near the middle, some are dangerously close to the edge. Technically, many parts may still pass inspection, but your process has a high variation. This is where the process capability comes in. Cp and Cpk helps answer a much deeper question. Not just did the part pass, but can this process consistently produce good parts with confidence? Now, very simply, Cp measures potential capability of a process. In other words, if the process stayed perfectly centered, how capable could it theoretically be? Think of Cp as your process potential. The Cpk, on the other hand, goes one step further. Cpk measures what is actually happening in the real production condition, because real manufacturing is never perfectly idle. Machines wear, tools drift, materials vary, temperature changes, operator change, and a process that looks good on paper may slowly drift towards a specification limit. So, Theoretically, you can have a very good CP value but still have a poor CPK value. Why? Because the process may have potential to perform well, but in reality, it is not centered properly. Let's imagine two processes. The first process produces parts with low variation and stays centered between specification limits. That's what we want to see. A healthy CPK, a predictable process, and a low risk. Now imagine the process begins drifting towards one specification limit. Parts may still pass inspection today, but risk is increasing. That's why capability studies are so valuable. They help identify problems before defects reach the customer. Inspection tells you what already happened. Capability helps predict what could happen next. One simple way to think about it is this. ISO certification is like having traffic rules. Cp and Cpk tells you whether the driver can eventually keep the vehicle under control. You can have procedures, checklists, and policies. But if the process keeps drifting unpredictably, problems eventually occur. Compliance creates structure, capability creates confidence. The best manufacturers don't just ask, did the part pass inspection? They ask, is the process stable? Is variation controlled? Will performance remain consistent over time? Because world-class manufacturing focuses on preventing defects rather than simply detecting them. At the end of the day, certification creates structure, but capability creates trust. And truly great manufacturing organizations need both. If you found this video valuable, please give it a like and consider subscribing to Engineering Explained Simply. My goal is to make quality engineering, manufacturing systems, and process improvement easier to understand through real-world examples and practical experience. And in the comments, I would love to hear from you. What causes more problems in your workplace today? Poor systems or uncontrolled variation? And if today's discussion sparked your interest, stay tuned. In the next video, we will explore why passing inspection doesn't always mean good quality, and why some of the biggest manufacturing problems can remain hidden even when every part appears to pass inspection. Thanks for watching. I will see you in the next video.